So today we're going to discuss about the application of conductance measurement. There are many types of there are many implications of conductance measurement, but today we're going to discuss mainly two important applications. The first one is your determination of degree of dissociations of weak electrolyte, and the second one is your determination of ionic product of water. The rest will be discussed in later class. Okay, so coming to the first application, which is the determination of degree of dissociation of weak electrolyte. So when we are talking about degree of dissociation, so what is the degree of dissociation? Degree of dissociation, which is actually symbolized as alpha, is quantify how fast the ions will going to form from their electrolyte in the electrolytic solution. Okay, so mathematically actually it can be calculated by using this relation, where lambda m represent the molar ionic conductance of that electrolyte and lambda m not represent the molar ionic conductance at infinity dilution for the same electrolyte. Okay, so we can calculate the lambda m naught by using these two, can be calculated by using conductance measurement. Okay, conductance measurement, that means we can calculate first specific conductance, and from that specific conductance we can easily calculate lambda m and lambda m naught. Once we have the value of this lambda m naught, then we can have also the value of alpha, that means the degree of dissociation. That means degree of dissociation can be calculated from conductance measurement. So this is the first application. The second, coming to the second application, which is your determination of ionic product of water. So when we are talking about ionic product, the meaning of ionic product is that, so the product of the ions which are from that electrolyte. Okay, so here you see in this case we are talking about the ionic product of water. Okay, so we have to consider water. So when we will going to consider water as electrolyte, then what will going to happen? Water will going to form S positive ion and OS negative ion. Okay, so the ionic product of water, which is Kw, that means Kw represents the ionic product of water. Okay, so Kw is equal to the what? The product of ionic, the product of ions. Oh, the actually the product of the concentration of their ions. So the ions will be S positive and OS negative in water. So that means this is your ionic product of water. This is the definition, by definition. Okay, so now we have to calculate this one. So how are we going to calculate? So we cannot directly calculate the concentration of S positive and concentration of OS negative from conductance measurements, but indirectly we can calculate this. So let us go and discuss about this, how we're going to calculate this concentration. Okay, so we can calculate, suppose we can calculate the specific conductance of water experimentally. Okay, and the value of specific conductance at 25 degrees Celsius was experimentally found as 5.54 into 10 to the power -6 Siemens per meter. Okay, this is what? This is your specific conductance. So here actually in this figure you see this is the setup by using which we can calculate the specific conductance of water at 25 degrees Celsius. Okay, so this is experimentally found data. Okay, so now coming to the next page. Okay, so this is the next page. So here this is what? This is your K represents specific conductance. So specific conductance unit is Siemens per meter inverse. Okay, so let's suppose the water is inside 1 meter cube box. That means the volume of the water is 1 meter cube. So if you try to calculate the specific conductance or the conductance of the water, the whole water present in 1 meter cube box, then the conductance of that water molecules or that the whole water present in that box will be your what? Specific conductance value into the volume. Okay, so this is your the conductance or conductivity of the whole water present in 1 meter cube box. Okay, and that will be your 5.54 into 10 to the power minus 6 cm square. So this is your conductivity of that water, no, which are inside this box. So experimentally also we can calculate the value of molar ionic conductance of water, and this was found that the molar ionic conductivity of water at 25 degrees Celsius is 548.3 into 10 to the minus 4 cm square per mole. Okay, so here we have the value of molar ionic conductance, and we have also the conductivity of water in 1 meter cube volume. So this is what 5.54 into 10 to the power minus 6 cm square. So here by using these two data we can calculate the number of hydrogen ion, S positive ion present in 1 cubic meter. So let us calculate this one. So let us calculate the number of S positive ions present in 1 meter cube volume. Okay, so that will be what? It's just we have to divide this one by this one. When we are going to divide this one and this one, then what will we get? You see, 5.54 into 10 to the power minus 6 cm square divided by 548.3 into 10 to the power minus 4 cm square per mole. So here the unit cm will going to cancel out, meter square will going to cancel out, then it will going to give you a value which is actually 1.01 into 10 to the power minus 4 mole. Okay, so this is the number of mole present in 1 meter cube. So here it is given here, is it this one? Okay, so this is the number of S positive ions present in 1 meter cube. 1 meter cube okay box. Okay, so that means the concentration will be what? That means the concentration of S positive ion will be 1 minute. Yes, just running. So the concentration of S positive ion will be 1.01 into 10 to the minus 4 mole, no? This mole per decameter cube. Why we are writing decameter cube? Because it is present in what? 1 meter cube. 1 meter cube, that is one. This one, no? So this is your concentration of S positive ion. So that means we are able to calculate S positive ion concentration from where? From the conductivity data, and this data will be calculated from where? Or this data can be calculated from conductance measurements. That means we can calculate the conductance. We can calculate the concentrations of S positive ions by using conductance measurement. Okay, so once we can calculate the this is what the concentration of S positive ion, we can also calculate the OH negative ion concentration, because H positive ion concentration is equal to the OH negative ion concentration. Why? Because you see the number of H positive will be equal to the number of OH negative ion. For 1 mole of water we will get 1 mole of H positive and 1 mole of OH negative ion. So that means the concentration will also be equal. So that means H positive ion concentration is equal to the OH negative ion concentration is equal to this one. Understand? No? Okay. So we have, that means we have the H positive concentration, OH negative concentrations. Okay, and again we are able to know that OH negative is equal to H positive. Okay, thus we can put this value in the formula of Kw. So Kw is equal to H positive into concentration of H positive into concentration of H positive into concentration of OH negative. So just put this value and we will get the Kw value as 1.02 into 10 to the power minus 14 mole square per decameter to the power minus, actually decameter to the power minus 6. Okay, so it is almost equal to 10 to the power minus 14 mole square decameter to the power minus 6. So that means we can also even calculate pKw, and pKw is equal to what? pKw is equal to just 14. Okay, so this is the one applications which is the, actually this is the application of conductance measurement. Okay, that means this OS positive, this OS positive, this OS positive, and the S positive and concentration can be calculated from conductivity. Okay, which is actually the value of lambda m and the conductance of water which are present in 1 meter cube box. Okay, so by using that value we can calculate the concentration of these two and just put this value here in this equation and we can calculate the value of Kw. Hope you understand these two applications. So in the next class we're going to discuss about the solubility product, the calculation of solubility product for sparingly soluble substances by using conductance measurement. Thank you.